Hi everybody, welcome to CES 2019. We are going to showcase and take you through the demos that Texas Instruments has put together with our partner D3 Engineering. Scott is here as well. Scott is going to take you through all the demos. What we have running is demos on front camera analytics for ADAS that enable up to level 3 class of automation to drive vehicles safely. We are also going to showcase parking assist algorithms as well as surround view, and we are going to take you through the radar and camera fusion algorithms that are running on TDA, Jacinto and AWR devices as well. Over to you, Scott.
Thanks a lot, Ash. I'm Scott Reardon with D3 Engineering. I'm excited to be here at CES. Our demo vehicle is loaded with TI technology. As Ash said, there's a handful of demos, and we'll walk you around the car and show you these demos. So we have a handful of sensors on the front of the car here. All are fed back to the compute bed in the back of the car. But this has a 2 megapixel camera from Sony that's stitched into 4 cameras like it around the car for surround view. We have a forward radar, mid-range radar, an 1843, a new device from TI. Does forward radar, does clustering algorithms all on chip. And then we have multiple radars that are stitched together to create a 360-degree radar bubble around the car. It can be used for parking, it can be used for autonomous control, and such. So there's 2 forward camera demos inside the windshield here. One is a 1.2 megapixel, one is a 1.7 megapixel. They're running forward single camera algorithms such as lane departure, pedestrian detect, vehicle detect, traffic sign recognition. On the side here, under the mirror, is a mirror replacement camera, low latency camera, shooting back in the blind spot area with a live display inside the car. Okay, these 2 sensors here are part of the surround radar system. Again, they feed in and give a 360-degree bubble of radar around the car. On the back of the car is the last of the surround view sensors, again a 2 megapixel. And then inside the back are all the different processor boxes. These are rugged ECU boxes, development kits, available from D3, reference designs as starting points for either automotive, industrial vehicle, or robotics, anything in the autonomous or ADAS space. Some are based on TI's TDA3 processor. Other ones, such as this, are based on the TDA2, and a recent addition is the TDA2 Plus. They can take anywhere from 4 to 8 SerDes inputs in, so cameras and radar. They also have other inputs, CAN bus, they're automotive rated parts. It's a 12-volt automotive input, so it's safe to put in a vehicle. They're weather tight, they have a debug panel. They're really good places to get started either on an A-sample or R&D projects on automotive, robotics, or industrial vehicles. This is a 1843 demo. This is a brand new radar, millimeter wave radar part from Texas Instruments in the 77 to 81 gigahertz range. It has 3 transmitters, 4 receivers, and what you're looking at is a ruggedized version development kit from D3 that allows you to go on vehicle, plugs in 12 volts, and can run out of the box. It's actually all the algorithm is run on chip. So this is a radar device that has the RF section, the FFT generator, and a DSP processor on chip. This gives you 3-dimensional data. So the plots on the lower right is showing actually a z-axis, so how high the cars are, or maybe reflections off lights or signs that you would see, radar reflections. The upper right-hand plot is Doppler, tells you the speed of the objects coming. All right, so this is a forward camera demo running on a rugged ECU from D3 with ruggedized cameras, and the algorithms provided by one of our algorithm partners, Hella. This is a forward camera, single camera algorithm. It does, as you can see, vehicle detection. It'll do sign recognition. It'll do lane markings. It'll do standard forward camera algorithms. All runs on a TDA2 processor and available from Hella Aglaya. This is a forward camera algorithm from one of our partners, StradVision. Again, this runs on a D3 rugged ECU with using some of our ruggedized cameras. Our algorithm partner StradVision, again, provides forward camera algorithms. They're doing lane detection. They're doing object detection of vehicles, people, classification. As you can see on the graphics, the boxes tell you the size of the object, distance to object. You can see the lane markers come up live. And this is running on a TDA2 processor. in a rugged on-vehicle platform available from D3. So this is a multiple radar demo. We call it Occupancy Grid. What you're seeing on the screen and outside is we have 6 radars all connected over CAN bus to a centralized processor, and we're essentially mapping out where everything is in the parking lot. So you'll see as we drive around, the fronts and backs of cars get filled in. You'll see empty parking spots become obvious. You'll actually even see the side of the building that we're near fill in. And this is from, again, 6 millimeter wave devices around the vehicle. 1843 is a new part from TI. They actually do the processing out on the edge. This is a part that has a DSP as well as an FFT engine as well as the RF engine all in a single chip. Then over CAN bus, we send the solution back to a centralized processor, uses an IMU and a GPS, and we mux all this data together in a system. It produces this output. So you're seeing now surround view. This is actually 2 megapixel surround view. So we have 4 2 megapixel cameras around the car. 1 in the front, 2 under the mirrors, 1 in the rear. And they're wide angle, 190 degree field of view cameras. It gives you a 360 degree bubble around the car, situational awareness of the video. And then what we can do is we can output that and combine it together in any way we want. The main mathematics behind how this works is photogrammetry. It allows you to stitch all the different cameras together and then move the user around within the frame of the video. The surround view algorithm is provided by one of our algorithm partners, Cogent Embedded. They make a production quality surround view. It also has features on it such as pedestrian detect, parking assist, and you can see the steering lines and other things are hooked up to the CAN bus. All that overlay information is provided in that graphics library. The demo you're seeing now is a CMS or mirror replacement demo. This is a new technology that will either augment what you see in your mirrors or replace your mirrors. So both side mirrors and rear view mirror. It has to be low latency, it has to be safe. You're seeing a OVT 10640 camera on the side of our car running in a low latency mode using a TDA processor. Thanks a lot for looking at the car today. These demos are available on our website from D3 Engineering. They're reference kits you can buy today and put on a vehicle. And lots of good technology from TI here at CES.
Thank you, Scott. Thanks for taking us through all the demos that are running on the car. The demos enable totally scalable safety solutions on the road on TI의 ADAS. So please have fun, leave us some feedback, and use TDA. Thank you.
Thanks.